on the Desmos graphing calculator, in the keypad or keyboard that it has, if you go in there, you'll see something that says functions, or it may be shortened FUNC, either or. When you go into that and scroll all the way to the bottom, you'll see something that says GCD. That's what we're going to be using. So that stands for greatest common divisor. So that's similar to our greatest common factor because we're looking for something we can divide out of everything. So similar, same thing. Okay. So as we are doing this, so like the very first card is 2, and I'm going to be showing these on the board so you can also see them. And then I would say, who has the GCF of 64y to the third minus 56y squared plus 88y? So if you know off the top of your head, that's great. If you're not sure, or maybe you want to double check yourself, you could put in these 3 numbers, 64, disregard that it's negative, so 56 and 88, into that Desmos. Inside the parentheses, put in commas after each number. And it'll tell you what that GCF or GCD is. Again, it won't tell you what the variables are, so you still have to figure that part out. But we know now that this next one will at least start with 8. So look at your cards. If you are one of the people who start with 8, it might be you. So look at the variables and see what that would be. Also, does anyone want a second one? It's okay if you don't. So look at your cards, help each other. Someone may have it and may not realize it. If yours starts with an 8, look and see if the variable also matches. Make sure I didn't have that. If you think you have the answer, you can say it out loud. Look at that. See if there's matches. See if there's matches. It has an 8. Is the variable match? Go ahead and read that out loud. So you can say this whole thing or this whole thing. So Terrell just read off this one. So be on the lookout for who has that next GCF. Use the Desmos if you need to, but you still need to figure out the variables. I should also be making sure it's not one of mine. Sure, there's like 6 up here, so
Okay, I'll take 3.
okay. Okay, it's not one of mine. I also have the list, so I can see who's next. What would the GCF number be? 4. So anyone who has a 4 on yours, look and see, do your variables match? If you're not sure, we can talk about it. So who has a 4 on there? Okay. So bring me yours. Alright, so x squared y, would x squared be the largest amount of x's we can have? Yes. What about 1y? Yes. So you are next. Go ahead and read your card. That might be me. Yeah. All right. 3x to the 5th, y to the 3rd. Who has the GCF of 56x to the 5th, y to the 4th, plus 42x to the 4th, y to the 3rd, minus 28x to the 3rd, y squared? What's that GCF number? I think. Okay. 14. So someone that has a 14, look at yours, see if your variables match. Emma? What is your second? So x squared, y squared. Is 2 the highest number of x's we can take, or that those have in common? No. So not yours yet. What is the highest number of x's we can take out of those? 3. So someone that has 14x to the 3rd. Oh, my bad. I'm sorry. That. Go ahead and read out your card.
You just hit yourself.
X squared minus 6x. So whoever has that is next. Does this one have a number, GCF? No. So just variables. Sid. It is X. Do you have that card? Go for it. X to the 3rd.
Y plus 9x to the 2nd.
And Miss Larson, can you grab Sid's card? Let's put it on up here. Does this one have a number, GCF? No.
No. That's not the variable.
X squared, yeah. So someone who has x squared, look for yours. We're not adding or subtracting them, so they're not going to cancel. But these do have a y in common, so yes. The y would be part of the GCF. So if you have x squared y, that's you.
So then I go ahead and ask for my GCF.
Where's the GCF? Okay, 8 to the third, or 8x to the third plus 4x squared plus 12x.
Whoever has that next GCF. I also don't have it. What's that GCF number? 4. Do they have anything else in common? X. So whoever has 4x, you're up. Whoever has that GCF.
Oh, wait. I got 20.
It is 20. Go for it.
So who has the GCF of 2x squared plus 8x?
What would that GCF number be? 2. Do they have anything else in common? X. So whoever has 2x, that is you. Go for it. What number can you go into the 7.5 then? 5. So see if you have a 5 on your card.
I mean, I have a 5.
What else do you have? Let's see if it works.
X2, Y2.
X squared, y squared. Is 2 the highest amount of x's we can take out? Yes. What about 2 y's? Is it the highest amount we can take out? Yes. So you were right. You were next.
Okay, who has the GCF factor of 7x4 negative 35 x squared 3 minus 14x squared?
Does this have a GCF number? This 7. Does it have anything else in common? X squared. So if that's you, you're next.
It's a really big number. Who has the GF of 12x squared 2 fifths y squared plus 9x 2 fourths y squared minus 6 2 thirds y squared.
Good job.
Can you repeat that?
A lot of numbers, a lot of variables, a lot of exponents.
Really? So much.
It's only like two.
Really? No, I wasn't aware of that.
3 is the GCF number. What about our variable? X to the third, y squared, yes. Anybody have that one? Say, I don't. I don't either. Okay, go for it.
Who has the BCF of 45 x to the second minus 20x?
Who has that GCF? It is 5. Anything else they have in common? X. So who has 5x? Go for it.
Who has the GCF of 49x y to the third plus 28x y?
I got it. So 7x y to the third. Okay, who has a GCF of 6x to the 8th power times or plus 10x to the 6th minus 3x to the 4th? Yeah, you gotta hit the switch. I'm not laughing. That was me again. It's on. Okay, cool. Do these have a number in common?
No. You don't have a number in common because of that 3 root.
Yeah, that's 3. The 6 and the 10 were good. The 6 and the 3 were good, but yeah, they don't all have one. So how many x's do they all have in common? 4. So who has x to the 4th? Okay, so go ahead and read your card.
Who has a GCF of 15x cubed times y minus 35x squared times y squared plus 40x times y cubed?
There's a lot. I'll take that. That might be me, actually. What's the GCF for the numbers, guys? 5, 1x, and also 1y, so yeah, that's me. Right, 5xy. Who has the GCF of 9x to the 3rd plus 30x? There's only so many of us. So. Right. What is that GCF number? 3. Anyone have a card that has a 3 on it? Go for it.
Who has the GCF of 72x 7y plus 24y?
Okay. So 72x to the 7th, y plus 24y. I feel like someone said it. Yep. Okay. Okay. to the 5th, 24x to the 4th, minus 30 plus 36x to the 3rd. That's not me.
I have 12x cubed, which has 144x to the 8th power y2 plus 27x to the 4th power y plus 9x cubed. Squared.
Is 20. Go for it. It is. We'll see how much we can get done in the next minute or two. Go ahead and read yours. Aaron, go ahead and read yours.
What is the GCF of 8x to the 5th minus 15x cubed?
What do they have in common? X cubed. You have that, you're up. So you go ahead and read your card.
Who has the GCF of 8x squared y minus 8x y squared?
Is that yours?
What's the GCM of 30x to the 6th, minus 75x to the 4th,
30x to the 6th minus 75x to the 4th minus 15x. It is 15x. Do you have that one?
Yeah.
Okay.
Who has the GCF of 18x cubed y squared plus 24x squared y squared?
We get this last one, we'll pause and finish after lunch. Don't take your cards with you to lunch, leave them on the desk, and then we'll finish. So we still have to figure out who has the GCF of 18x to the 3rd y squared plus 24x squared y squared. So I gave you this. It is 6. I wonder if that was mine. Definitely my bad. So 6x squared y squared. Who has the GCF of 7x minus 7? Read yours.
I think, but it's just 7.
Yeah.
Okay. Who has the GCF of x y squared minus xy?
What do those have in common? One x and one y. Who has that? Go ahead, Sid.
Who has 27x?
Yep, keep going.
To the 3rd minus 18x to the 2nd plus 45.
So who has that GCF?
That's 9 to the x. That's 9x.
Who's my next? Yes, me.
Okay, who has the GCF of 32xy minus 18y?
What would that number be? 4, say it again. 2 2y, yes? So then read that next one.
X power plus 8x to the second power plus 6x.
I think that's yours. Go ahead and read that one. And you can just read this one.
Who have the DCF of A, X,
Mm-hmm. And that was the first card we started with, which was 2. So good job. Thank you for participating. Can you help me to see it? So I wanted you guys to review GCF because what we're about to do is not really GCF stuff, but we'll have some GCF stuff in it. Alright, so just like when we did GCF, we're going to do this warm-up so you can see kind of what we are looking for, what we start with. So we're going to multiply these together using that same method as before, taking the first terms and multiplying them together. So x times x would give us what? X squared. X times negative 4. Just x times negative 4. What would that one give us? Negative 4x. And then the inside's 4 times x. What would that give us? 4x. And then the last one, positive 4 times negative 4. That one. Then we could combine our like terms. If we do that, what happens? The x's cancel, leaving just x squared minus 16. Okay. Same thing for the next one. Multiply the first two together. 5m and 5m would give us what? 25m squared. Okay. 5m times negative 1. Negative 5m. 1 times 5m. 5m. Positive this time. And 1 times negative 1. Negative 1. So again, same thing happens. This should be 25, not 5. But, so then the insides or the two middle terms cancel each other out, just leaving 25m squared minus 1. Anyone want to take a guess as to what the final answer for this one would be? not, we can also do it. 2a times 2a. 4a squared. 2a times negative 3b. Negative 6ab. 3b times 2a. So whether you put AB again or BA does not matter. You're still going to end up combining them. And then 3b times negative 3b. Negative 9b squared, yeah. Right, so what would that final answer be? A squared minus 9b squared. Right? So for these set of factoring, what's going to happen is we're going to be given things that look like this. X squared minus 16, 25x squared minus 1, things that look like that. And we're going to have to find the factors for them. So in order to do that, we have to follow these steps. First, we have to make sure that the numbers or the terms we have are perfect squares. So think about 1 times 1, 2 times 2, 3 times 3, so on and so forth. Those are your perfect squares. And then perfect square terms are either the numbers, disregard the negative, or if the variables are squared to the 4th, to the 6th, something even. But usually for right now, you'll just see squared. So if that's the case, and you're subtracting, then we have what is called a difference of squares. If we have a difference of squares, we can do the following. It'll look something like this. Maybe you have numbers, maybe you don't, it depends. You're going to have two sets of factors. And you have to think about what times what will give you the first term, what times what will give you the second term. So in this case, what times what will give you a squared? A times a. So you would put that first in both sets of parentheses. What times what will give you b squared? Ignore the negative for a second. B. So put b at the back of both sets of parentheses. Then put a plus and a minus in between them. Does not matter if you put the plus first or the minus first, as long as you put both. And then if you wanted to check your work, you do what we just did and distribute it back out and see does it match the original. Okay, so let's do some examples. First, let's check and see, are these perfect square terms? A squared, is there something multiplied by itself that will give us a squared? Something times something equals a squared, is that a true statement? A, so yes. And then is 4 a perfect square? Is there something times something, that same something, that will give us 4? Yes. So if that's the case and we're subtracting, we said a times a would give us a squared, so put that in front. What times what would give us 4? 2. Put a plus, put a minus. Again, does not matter which one you put first. Questions so far? Okay. For number 2, n squared is like a squared, so that one is a perfect square term. Is 64. So when I start to change my wording and ask you for the factors of this would be n plus 8 and n minus 8. Questions on that one? In 3, it changes the order. That doesn't mean anything. You still do the same exact thing. 81 is a perfect square. When you write your factors, you're going to write it exactly how you see the original. What times what will give us 81? 9. So you would put the 9 first, your plus or minus, and then x times x would give us x squared, so it would just look backwards. So you put it in the same format as whatever you see. Questions so far? Let's jump to 5. What's different about 5 than the others? Mm, 25 is a perfect square. K squared is a perfect square. Something else is different. It's adding. So if you see that these are perfect squares, but this is adding, we cannot do anything else with it. This becomes prime. Okay. Notice that this prime is different than the GCF prime because we're not dividing something out of both besides 1. So yes, in that sense, it's also prime. But also we can't do the difference of squares factoring, which is also why it's prime. Let's try 6. So now we're adding more numbers, more variables. Still doing the same thing. What times what will give you 1? 1. And then what times what will give you 49y squared? 7 and y. You would put those together. Yeah, 1 should be minus. Yeah, correct. Let's try 7. What would those two factors be? So think about what times what will give you 9, what times what will give you b squared, what times what will give you 100. 3. And so really, once you know one, you know the other. Just change the sign. Let's skip to 10. What would those factors be? X plus 9y. X minus 9. Right. One more from this page, then we'll move on to some more challenging ones. 11. What would those factors be? Two H. 5G. Okay. Questions on this process or anything so far? Go ahead and flip over to the back. You're still doing the same thing here, but now some of them are a little bit more challenging. So let's see, can we find the factors of 13? Let's see. Y plus 1 and that. Minus 1. For 14, notice that one of the exponents has an exponent of 4. You do the same exact thing. Anytime this exponent is not 2, but it's even, you're gonna just cut it in half, divide it by 2. So what do we think those factors would be? 9n squared plus 5, yes, or minus 5, the order does not matter. Write this in your open space. Let's say this problem instead said 81 n to the 4th minus 625. We know the first part would be 9n squared. What times what gives us 625? And if you're not sure, my calculator's not open. I think you're close. You can use this on your calculator. It's in blue, so you have to use second and then x squared. And then type in 625. 25. So then our two factors would be 9n squared plus 25 and 9n squared minus 25. One of those factors we can't do anything else with because of the addition. But the other one, are these perfect squares still? So we have to break it down again. So be on the lookout for things you have to break down twice. So what would the factors from this be? Would it still be squared?
No.
So this one would have 3 factors instead of 2. Not many problems do that, but some do. So just be on the lookout for that. Look at your final answers. Make sure you can't break it down again. 15, I think, was a typo. Because 5 is not a perfect square. Even though 4, c squared, d squared, those are all perfect square terms, we can't do difference of squares if not everything is. So this would be considered prime. Now if it's at 25, then we could do it. But it does not. Let's try 19. Just like the r to the 4th, you're doing the same thing here. What do we think those factors would be? 2 plus 1 and Before we move on to this next section, do we have any questions we skipped over up to 20 that we want to go back and see, have questions about, do any of those? If not, let's move on to the next section. Okay. First, I want to say this. When we were doing grouping, I said if you have 4 terms, grouping is what you would do with it. That's the only thing you can do with it. If you have something that has 2 terms, you can only do 2 things with it. Either find the GCF, or do the difference of squares, or it might be a mixture of both. But those are the only things you can do with 2 terms. So I would say check for a GCF first, because it may have one, and then you could do something else with it. It may have one, and then you can't do anything else with it. It depends. So with this first one, does it have a GCF? And if so, what is it? Do they have something in common? as you're practicing, you can still use the Desmos GCD. Just don't rely on that too much, because you won't have that for the test and quiz. What did these have in common? These two, yes. If we're dividing these both by 2, what's left? What would be left inside those parentheses if we divided everything by 2? N squared minus 36. Then inside, can we use GCF again? Do they have anything in common? No. What about, are they both perfect squares? Is something times something equal 36? The same, and it has to be the same number? 6. So that means we can factor this more. Always bring down your GCF. What would those 2 factors be? N plus 6 is one of them. What's the other? Okay. So sometimes you'll have a GCF, sometimes you won't. You just have to pay attention to check for GCF first and then see, can you do anything else with it? Let's skip to 24. Do those have anything in common? Five and Q. So if we're dividing both of those by 5Q, what's left? Q squared minus not 5, but 4. What can we do with that inside?
Did that go smaller, guys?
Yes, using GCF or difference of squares. Do you have something in common? Not GCF? Can you use difference of squares? Yes. So what would those 2 factors be? 3Q is Q. 3Q plus 2. And then 3Q minus 2. I just want to do a few more and then any others you guys want to see, and then you'll have time to practice. Okay, so let's start with 26. As you're looking at 26, you may recognize that 136 are both perfect squares, but b to the third and b are not. So that would tell you there's a GCF. And even though 136 are already perfect squares, you still have to see what those have in common and divide something out of there. So what would that GCF be? works, but it's not the highest. 4 is the highest, yeah. So 4 and anything else?
4 times
Bless you. 4b. So if we're dividing both of those by 4b, what's left? 25 b squared minus 9. Can we use GCF or DOS? I was going to say DOS. Can we use difference of squares or greatest common factor for the anti? Which one? Difference of squares. So what would those two new factors be?
5 plus 2.
And then minus. Okay. For 27, do those have something in common?
number?
27. What do we think? Do those have something in common? Remember, you can use the Desmos if you're not sure about the factors. You could list out the factors if you want to do that. 2 works. It's not. I'm sorry, 2 doesn't work because the one from God. Oh, I'm sorry. 5 would work. Do they have any ends in common? N squared. If we divide both of those by 5n squared, what's left? N squared minus 25. This one doesn't have GCF, so we can use those. Difference of squares, what would those two factors be?
8 times plus 5.
8 times 8 give us 16?
Oh. 4.
4n plus 5, 4n minus 5. Right? And then 28 is the last one I want you guys to try. Does that one have a GCF? If you divided that out of both, what would be left? Are there any others in that section we want to see, go over, have questions about? Hard. Okay. So for 32, do those have something in common? Not numbers, or not any numbers, but variables. Do they have any in common? M and N, one N. So if we're dividing each by one M and one N, what's left? How many M's would be left if we had 3 and took one out? 2. Would we have any N's left there? No. If we had negative Mn and we divided it by Mn, what would be left?
Doesn't necessarily cancel out, but what number shows up? What invisible numbers? One.
So then we have perfect squares. What would those factors be? M plus 1 is one of them, yep. And then the other? Yes. Alright, so if you were paying attention, then the 2 Khan Academies should be a breeze for you. You could get them done in no more than 10 minutes. One is just on difference of square stuff. The other one has GCF in it. I don't remember which one is which. Let us know if you need help with those. If you did not do the one from last Friday, make sure you get that one done. If you want more practice, you can go back and do the notes on here. Let us know if you have any questions.